So at this lesson, you see in the first lesson video for today, go over the overview of equivalence concept. And we now use different equivalence formulas, equation in engineering economics problems. And we also use the tables that have in the FE reference, fundamental of engineering FE exam reference. And I use that for exam 2 reference for this class. So we try to use both and try to go back and forth for the equation and the table that we use in the reference for all of the equivalence formula we have it here. So let's first one equivalence equation that we want to determine is the derivation of a single payment factors. So what the factor we have it in here, that is the factor f over p and p over f. F over p, that factor, and p over f. And F in this class, it stands for future values. P stands for present value. For those of you are not familiar with PF, go to see the first lesson video for today class. We define what is F and P, etc. So let's draw a representative diagram for cash flow diagram for these scenarios. So if we have a scenarios, years or month, at a present time, we have time 0. We deposit an amount, and that present time is 0, is present, it's P. And at year 1, 2, etc. And then at year end, certain year in time, certain year or certain month. So it can be years, or can be month, or can be quarter, etc. Any. Then we withdraw the amount in future that we call it F, future value. And with the interest is I% per years or per month, depends on the question we are talking about. And then the question is, what is the relationship between the present value P at time 0 and the future value F at time N in the future? And like I say, to have that, you need to go to know what is F and P in the first lesson video. So if at F at year 1, so what will I say for F year 1? So if we have F at year 1, then it equal to original principal plus the interest in the first year, so P times I. Everyone understand that, right? For if it F happen at year 1. So from that we can have it P1 plus I. Now if F withdraw at year 2, then we have it, this is compound interest, original principal at the end of year 1, that is F1, plus the interest accumulate in the second year, F1 times I. And from that we have it equal to F1, 1 plus I. And since F1 equal to P1 plus I, then it will be equal to P1 plus I times 1 plus I. And that is P1 plus I power 2. Power 2. Everyone see that? So with that one, as you can see, then we will do by induction. So by induction for an interest period. That's what we want to find out. What happened with withdraw n period later, n years, n months later, and interest period. Then it can be f, and it can be Fn. And in that case, to make life easy, we just call that EF. And that equal to, as you can see, at year 1, I have P1 plus I power 1. Year 2, power 2, P1 plus I power 2. By induction, I can say that equal to P1 plus I power n. So bottom line, we can rewrite, you can rewrite and box. So f at any time in the future, if we have the present value, the value some time ago, so the equation it will be P1 plus I power n, n is the interest period. And if we use the table, that 1 plus I power n, let me write two different colors so that we can be able to find out. That is 1 plus I power n. So it equal to P, and the factor 1 plus I power n, if we use for the table, it call it the factor F over P with I percent for n years. And years 1 is a factor, not a ratio. This is a factor to use in reference. And I will go over in a minute, but that's what we have, that is factor. So not the F divided by P, but that what we have, it mean that not ratio, but like given P find F, given P find F. So what is given, go to denominator, find F. And that factor in that bracket, it will be 1 plus I power n. So similarly, if given the F future value, how to find out P? You just flip, so that it will be P equal to F divided by 1 plus I power n. Or I can say that it equal to 1 plus I minus n, power minus n, or divide by that number. And with that, we can use the factor in the table, that is equal to F. And in this case, they give us F and find out P. So it will be P over F, given F by P, I percent n. And again, that also a factor to use in the reference, nothing to do with the ratio. And that's why we say the factor F over P and P over F. So what does that mean? Let's go to the reference that we have here with the reference. You see the FE reference that you will take for the FE, and I use that for exam 2 reference available on Canvas. So given the first two, as you can see, single payment, 2F given P, so given P 5F, so we have F over P, I percent n, and the equation is 1 plus I power n. Given F 5P, then P over F, I percent n, or the equation is 1 plus I power negative n. So that the first two. And go down to the table, we do the same. The factor, for example, at interest 0.5%, then you have n with years, P over F, it means the factor given F 5P. Then you have other until here, F over P, it means given P 5F. So you can use either the equation directly or the factor. And that's the purpose we applied in the next problem. Problem 1 here. How much money should you will be willing to spend now in order to avoid spending 5,000 7 years from now if the interest rate is 18% per year. So how much money you spend now? So that is the present value. That is the question asked. Avoid spending 5,000 7 years from now. Something in the future. Future value. Given F, 5P, with interest 18% for 7 years. So it's good to draw a diagram. Cash flow diagram. So this is years. And now 0, 1, 2, 3, 4, 5, 6, 7. To avoid spending 5,000 7 years from now. So as you can see that avoid spending. So it means that you don't have to spend. That go up 5,000 7 years from now. What is the amount you should spend now? That is P is the question asked. And with the interest is 18% per year. So of course, as you can see that actually F, and given F5P, so we can use the equation from there. We have P, if we apply for equation, so P, let's do that, use equation. Then I have P equal F 1 plus I negative N, and that equal to 5,000. 5,000, that future value 1 plus 18 negative 7 years 7. So from that you get 1,569.63, and that if you apply the equation directly. Now I want you also use the table. Engineering want to use manual table, etc. Otherwise, and sometimes it's faster. So in this case, or use table. Use table. So what does that mean? We can go to still P equal to F, but in this case given F5P, so I can apply the factor P over F I%, in this case 18% per year, 18%. For how many years? 7 years. And what I just want to go to the reference and find out what is that factor equal to. Then we are done. So how to do it? The reference you have in here, the table from the FE reference, go down to the table that have, you see 2%, 4%, 6%, 8%, 10%, 12%, 18%. So we stop at 18%. Okay, so that go to that table, and that I have it in the slide here. You have that table there. So 18%, go to look for the interest table with 18%. And then what we're looking for is the, let me zoom in this table, zoom in. And we're looking for given F5P. So it's basically the second column you have there. So what do you have? 18%, P over F, 18%, 7 years. So looking for N at 7, P over F, so that is the second column. Then N, 7 years, and you can see 7 years, so we'll look for N 7 years. And the intersection of that factor is 31.5. 0.3139. That is the factor P over F, 18% and 7 years. Everyone have to read, and that's similar to other factor P over A, P over G. We will touch on that later on, P over F, F over P, etc. So looking for the interest table, exactly 18%. Then what factor you use, what n, you can be able to find out that number. So let's apply to here. That factor, if I use table, it's 0.3139. So the table use reference from reference. Then we can have that equal to 5,000 times 0.3139, and that also reference, and that equal to 1,569.50, and it a little bit up 13 cents. It's because that the round up, we only get, you see 3139 only get the 4 digits in there. So that the first concept that we apply in equivalence.